Hello everyone. Imagine it's 2028. Your AI application is finally delivering business values. Then your LLM provider retires the model you are using, or the pricing doubles, or a new compliance regulations is introduced. The business asks you to connect 5 new data sources and deploy 20 AI agents. Now ask a question to yourself. Can your AI system adapt without being rebuilt? If the answer is no, you have already made one of the biggest AI mistakes organizations will regret over next 2 years. They are investing millions in AI applications, but very little in the architecture that allows those applications to survive changes. Building an AI application is easy. Building one that still works after 2 years is the real challenge. In the beginning, everything looks simple. One model, one prompt, one data source. But as the business grows, so does the complexity. New models, new data sources, new integrations, new AI agents. If your architecture wasn't designed for that growth, every new requirement becomes harder, slower, and more expensive. Every enhancement becomes a major engineering effort instead of a simple configuration change. That hidden cost has a name. It's called AI technical debt. Today, let's understand how it forms and, more importantly, how we can prevent it. Today, almost every organization starts with the same question. Which LLM should we use? Should we choose GPT, Claude, Gemini, Llama, or the next model that just topped a benchmark? And honestly, it's understandable. Every week there is a new model claiming better reasoning, low cost, or higher benchmark score. Because of that constant innovation and a bit of FOMO, many organizations become obsessed with choosing the best model. Very few ask the question that will actually determine whether their AI platform survive over the next 2 year or 3 year. The questions like how will we replace today's model when it is retired tomorrow? What happens if the pricing suddenly doubles? How do we govern, monitor, and secure hundreds of AI agents? How do we prevent our AI architecture from becoming tightly coupled to a single vendor? Will adapting to future changes require changes a configuration or rewriting our applications? Those are architecture questions, not model questions. And when we ignore them, we begins accumulating something called as an AI technical debt. The real question isn't which LLM should we use today. The real question is, will our AI architecture still works 2 years from now? Why AI become complex? In the previous slide, I explained that choosing an LLM is not the biggest challenge. Let me explain why. Most people think an AI application is simply user application LLM and getting the response back. But that's not how enterprise AI system works. As AI solution evolves from a simple chatbot into an enterprise grade AI platform, the complexity grows exponentially. Today, an LLM is just one component in a much larger ecosystem. Around that model, we built an AI gateway for routing and model abstraction. We connect vector database to provide business knowledge through RAG. We integrate dozens of business APIs and enterprise systems. We deploy AI agents capable of planning and executing tasks. Then we add monitoring to track latency, cost, token, consumption, hallucination, and performance. We introduce security, governance, guardrails, compliance, and evaluation framework to ensure the system behaves responsibly. every one of these layers introduces new dependencies. Every dependency introduces additional maintenance, and every maintenance activity increases the probability of accumulating technical debt. Have you noticed something interesting here? The LLM itself is only one layer in the entire architecture. Yet most organizations spends almost all of their time debating which model to choose, while very little time designing an architecture that surrounds it. In reality, replacing GPT with Claude is often easier than replacing an architecture that has become tightly coupled to a single model. That is why AI technical debt is fundamentally an architecture problem, not an LLM problem. Evo- Evolution story of a chatbot. Let me explain AI technical debt with a simple story that almost every organization can relate to. Imagine an HR department wants to build an AI assistant to answer employee questions. In month one, it's simple proof of concept. There is one prompt, one PDF, and one LLM. The chatbot answers HR policies accurately. Everyone is impressed, and leadership quickly approves moving it into production. But success begins new requirement. The business now wants answer from SharePoint, SAP, Jira, CRM, email, Microsoft Team, and several other enterprise systems. Different business teams request different capabilities, so new prompts are added. New use cases require different LLMs, so multiple model endpoints are introduced. AI agents are added to automate tasks, and integrations continue to grow. None of these decisions are wrong. In fact, each one makes perfect business sense. The problem is that they are often implemented incrementally without a long-term architecture strategy. Now, fast forward to 12 months. The chatbot has become a mission critical enterprise AI platform. And suddenly, people started asking questions that nobody can confidently answer. Which prompt generated this response? Why did the answer change after last week's deployment? Which LLM is currently serving this request? Who owns this AI agent? Which integration is causing this failure? At this point, the organization doesn't have a chatbot problem. It has an observability problem, a governance problem, and ultimately an AI technical debt problem. The most dangerous part is that this debt didn't appear overnight. It accumulates silently, one feature, one prompt, one integration, and one model at a time. And by the time the organization notices it, fixing it has become significantly more expensive than preventing it in the first place. So far, we have established that AI technical debt is fundamentally an architecture problem. But AI technical debt is not a single issue. It doesn't come from one bad design decision or one poorly written prompt. Instead, it accumulates across multiple dimensions of an entire AI platform. Think of it as 8 different forms of debt, each growing independently but collectively making the system more difficult to maintain, evolve, and scale. Let's briefly look at them. Number one, data debt. We often hear that data is the new gold, but in AI, data is much more than an asset. It is the foundation on which everything is built. If the foundation is unstructured, inconsistent, outdated, or poorly governed, the entire AI application becomes fragile. A simple data drift, a schema change, or a change in business pattern can break prompts retrieval pipelines, or model outputs. Data that isn't created overnight, it accumulates silently as data evolve without proper governance, eventually making the AI system unreliable and difficult to maintain. Number two, prompt debt. Prompt debt appears when prompts becomes scattered across applications, difficult to version, test or maintain. Number three, model debt. Model debt occurs when application becomes tightly coupled to specific LLMs, making upgrades, migrations, or provider change expensive or risky. Number four, integration debt. Integration debt grows as we connect more APIs, enterprise systems, and external services, each introducing new dependencies and failure point. 5. Agent debt. Agent debt emerges when autonomous agents proliferate or without proper orchestration, coordination, observability, or life cycle management. 6. Evaluation debt develops when AI output are no longer systematically measured, benchmarked, or validated, causing quality to drift over time. 7. Governance debt. Governance debt accumulates when organizations lack visibility into model uses, cost, compliance, auditability, or policy enforcement. And finally, 8. Security debt. Security debt arises from vulnerabilities such as prompt injection, excessive permissions, data leakage, insecure tool access, and inadequate guardrails. The important point is that these debts doesn't exist in isolation. They reinforce each other. Improving one area with while neglecting another doesn't eliminate technical debt. It simply shifts where it accumulates. The organizations that succeed won't be the one using the smarter model. They will be the one that systematically manage all dimensions of AI technical debt. Architecture that prevent AI technical debt. So far, we have talked about how AI technical debt accumulates and why enterprise AI systems becomes difficult to maintain. The obvious question now is, how do we prevent it? The answer is pretty simple. Don't build around models, build around architecture. One of the biggest mistake organizations make is designing their applications around today's best LLM, but models are evolving at rapid pace. Today's state of art model may be replaced in 6 months. Pricing may change, provider may retire model, or a better alternative may emerge. If your application is tightly coupled to a specific model, every changes becomes an engineering project instead of configuration changes. So what's the solution? The solution is to build a layered architecture where every layer has a clear responsibility. Your applications should never communicate directly with LLMs. They should communicate through the AI gateway. The AI gateway becomes the central orchestrator of your AI platform. It handles model routing, authentication, rate limiting, load balancing, uh, retries, fallback strategies, and policy enforcement. This allows you to switch between OpenAI, Claude, Gemini, Azure, OpenAI, or any future model without changing your application. Equally important, your business knowledge should not live inside prompts or models. They should reside in the dedicated knowledge layer backed by enterprise data and vector database. This separates business knowledge from model intelligence, making both independently scalable. Finally, there are several capabilities that should never be treated as optional: governance, security, monitoring, observability, prompt registry, agent registry. and continuous evaluation. These are not additional features. They are foundation capabilities that keep enterprise AI platforms reliable, secure, and maintainable as it grows. When these architectural principles are in place, replacing a model becomes a routine operational decision, not a major software rewrite. And that's how we prevent AI technical debt from accumulating. Designing the right architecture is only a half battle. Architectures gives us the right foundation, but architecture does alone doesn't prevent technical debt. Engineering discipline does. There are five disciplines that I believe every enterprise should adopt. First, decouple models. Decouple your applications from AI models. Applications should never directly depend on OpenAI, Claude, Gemini, or any individual provider. Every model request should flow through an AI gateway. That gives you vendor independence and making future model migration a configuration changes rather than an application rewrite. Second, treat prompts like code. Prompts are no longer piece of text. They are business logic. If prompts influences customer decisions or automate business processes, they deserve the same engineering discipline as software code. Version them, test them, rewrite them, deploy them through controlled release process. Third, govern data. AI systems are only as reliable as the data behind them. Data should be treated as a managed enterprise assets. Maintain quality standard, metadata, ownership, lineage, and life cycle management. Good governance today prevents expensive data debt tomorrow. Fourth, measure everything. Traditional software team monitors CPU and memory. AI team must monitor much more, like latency, cost, accuracy, hallucination, user feedbacks, prompt performance. Because what you doesn't measure, you cannot improve. Finally, govern govern agents. An organization deploy hundreds of AI agents. They need the same governance as human employees. Every agent should have an owner, defined responsibilities, permissions, life cycle management, and clear operational policies. Otherwise, agent debt becomes inevitable. Have you noticed something interesting here? None of these five pillars are about choosing a better LLM. They are about building better engineering practices. Organizations cannot reduce AI technical debt by constantly changing models. They reduce it by constantly applying engineering discipline across AI lifecycle. AI technical debt maturity model. Throughout this presentation, we have discussed what AI technical debt is, how it accumulates, and the architectural and engineering practices that helps to prevent it. The final question is, where is your organization today? The most organizations begins at level 1, building a simple prototype with a single model and little or no governance. As AI initiatives prove successful, they moves into pilot and production, where multiple models, prompts, and knowledge sources introduces new operational challenges. The real transformation happens at the enterprise level, where AI is no longer just an application, it becomes a managed platform with governance, security, observability, and standardized architecture. And ultimately, the goal is to reach level 5, an AI platform that is vendor independent, scalable, continuously evaluated, and designed to evolve as technology changes. The objective is not to reach level 5 overnight. The objective is to know where you are today and deliberately build towards the next level instead of allowing AI technical debt to determine your future. Build platform, not application. Let me leave you with one final thought. Throughout this presentation, we have talked about AI technical debt not as a software problem, but as an architecture challenge. We have seen how organizations often focus on choosing the best models, while the real risk lies in building systems that cannot adapt to change. Because change is inevitable. Models will change, vendors will change, prompts will evolve, your enterprise data will continue to grow, regulations will become more demanding. Even the way we build AI today will look very different just a few years from now. None of those changes are the problem. The problem is an architecture that cannot absorb those changes. That's why I believe the future belongs to the organizations that stop thinking in terms of AI applications and start thinking in terms of AI platforms. Platforms that are vendor independent, platforms that are observable, platforms that are governed, platforms that are designed to evolve, not to rebuild. If your architecture can survive the next model, the next framework, the next regulations, and the next wave of AI innovations, then you have built something that will continue creating values long after today's best model has been forgotten. So don't build around today's model, build an architecture that's really for tomorrow's innovation. Thank you.